So thank you for having me here at the SharkFest Europe conference. I'm really happy to share a little part of what we are doing almost every day on this tool called Scapy. So another short introduction. So I'm Guillaume Valadon. I'm French. I'm mainly a network and security enthusiast. Indeed, when I start my career, I was doing networking, and I start by working on stuff like DNS, TLS, BGP, and IPv6. And later on, let's say 10 years ago, I start to switch to security. So one part of the example I will present today are also not only related to networking, but also I will present some security exploit and some usage of Scapy regarding security. And today I'm here to share a part of the Scapy history with you. And so far it's only been known by the maintainers, which are Philippe Biondi, Gabriel Potter, Pierre Lallet, and me. So if you need, you can get the slide at this link, but I've seen that I've shared them on the Discord channel, so you can also click on that, or if you want, you can take a picture of the code. It might be easier to follow while I'm presenting. So if you don't know, I will spend like a few minutes to explain what is Scapy. So briefly, it's a tool that simplifies network interaction. It's written in Python, so it means that you can use it as a module, or you can use a shell like regular Unix shell, and then you can type commands to interact with the network. Scapy simplifies your life, so it means that with a single line, you can define a packet and send it. So here on the screen, what we are building, that's an SCMP packet, that's a echo request to the SharkFest Europe website over IP, and then we will put this packet over Ethernet. And SRP1, that's a function that will build the bytes that correspond to this packet. It will send these bytes and then receive one answer. And the answer, that's a Python object that you can play with. And to me, one of the most interesting features of Scapy is that it's really easy to add a new protocol. What you need to do, you need to create a Python object, define a list of fields. For example, you want a field name, destination address, source address, checksum, and Scapy will automatically constrict the packet, and also it will be able to parse raw bytes and give you back a Python object. On top of these features, we have many things inside. For example, you can directly from Scapy and without any external dependencies read and write pickup files. Again, that's really interesting. For example, if you are sniffing packets with Wireshark and at some point you want to have a look at a specific field and being able to interact with the packet, let's say with a more programmatic way and with Python. We support a wide range of protocols, of course, regular ones for IP, like IPv4, IPv6, DNS, TLS. And we also have the support for a wireless protocol like 802.11, Bluetooth Low Energy, and ZigBee. The tool is multi-platform. It means that you can expect to use it on Linux, macOS, BSDs, and Windows the same way. On Windows, you need to install npcap.dll because that's the way we are actually interacting with the network. We need this specific library to talk to the Windows kernel and to the network. On the other platforms, so Unix-based, there is nothing you need to do. Just clone the Scapy repository and you're good to go. So briefly, if you never did that before, you can start by cloning Scapy, entering the directory, and then start the run Scapy as a privileged user. In that case, Scapy will start and it will give you this shell here at the bottom of the screen. And you are ready to type Python code and ready to type, let's call them Scapy packets. So here, that's a brief example that I won't detail, but what is going on here, we are building a weird TCP segment. The flag will be a reset. It's really strange, usually it's not a packet that you send. And then we'll ask Scapy to send 256 IP packets. So why? Because we are providing not a single address, but a full IP for a prefix of 24 bits. And SR means send and receive. So SCAPI will send this packet, and it will give you back a list in R. And R is a list of packets with queries and answers that you can play with, for example, here in Python. So if you don't know Python, that's a bit scary, but just a simple way to play with a list and iterate over values. So again, gives you a really powerful access and low-level access to packets, and you can check the value of any fields, compare them, and so on. And also something you could do is save the R packet list into a pickup if you want to open it with Wireshark, for example. Some numbers. So SCAPI is 18 years old. It was released in March 23. So for us French people, it's really interesting. It's a really important date because in France, it means that you are allowed to drink and drive. So that's why 18 is an important number for us. So SCAPI was developed by Philippe Biondy since 2003. And since 2012, he asked us, Gabriel, Pierre, and me, to take over the project and maintain the project. And today there is 3 maintainers that are trying to actively update the code. Since 18 years, we have been lucky. We had more than 300 contributors. As of today, there is 5 regular ones. So it means that on a daily basis, we receive, let's say, between 2 and 5 pull requests, which is okay for us and it makes the project evolve in a nice way. When I made these slides, I had a look at the PyPy installation. So PyPy is a Python package system, and it seems that people are, there's 50,000 installation of SCAPI per day, which is also an interesting number. But to me, the big surprise is that there's still a lot of Python 2. And why is it a surprise? It's because Python 2 is supposed to be end of life. And even though people are not supposed to use it, it's more difficult to use it. The main part of our users are still using Python 2. So on the project management side, so that's not like what we do the best. However, we'll briefly try to describe what we aim to do. So SCAPI is developed with the best effort, let's say, in the best effort way. It's only a volunteer work, so it means that we are not paid to develop SCAPI. However, I need to thank our employers because they are really supportive. So when we need to fix a bug, or if we need to take time, or like today, take time to give a keynote or tutorial, they are really supportive and they always say yes. That's a big thank to them. We recommend to use the master branch on GitHub because the code is fresh and most of the time there's less bugs. And we try to do an annual release, so there's no date. So we don't release in December or in March. So we release when the code is ready, but usually we do 1 per year. And we try to do that to ease maintainers package maintainers life. For example, people in Ubuntu or Debian, it's much more easier for them if we release a SCAPI version per year. Okay, so that's a brief SCAPI presentation. Again, it's not a technical presentation about SCAPI, so I would just give you a quick technical details or some line of code that you can use. And before discussing the SCAPI history, I would like to briefly explain what was life before SCAPI. So if you had to interact with the network, if you had to inject some packets and read back the answers, you had to write a lot of code and do a lot of things yourself. For example, read the network, read bytes from the network, parse them as a C structure, for example. You need to do the same backward. You take the C structure, convert it to bytes, send it. And on the way, you need to take care of many different things depending on the protocols. For example, for TCP/IP, you need to compute the checksums, the lengths. You need to take care of the routing and source address selection. That's a lot of code you need to do. But it's nice in some way because it gives you a complete control on packets. you can put any value to any field, but that's still a lot of code. For example, if you just want to send a simple echo request message. Some libraries were released around the, so it depends, DNet, I think it was 2002, 2003, pickup, that's really older libraries. But these two libraries, they give you, let's say, simplified access to network. Pickup is your life when you want to sniff, and DNet, on the other hand, help you when you want to inject. So before Scapy, there was another tool called HPing. So HPing, that's a command line based tool that's, again, simplify your life. So in that example, we'll send an SCMP echo request message to the SharkFest Europe website. So again, really simple if you want to ping. It's a bit more powerful than that, obviously, because you can send TCP segments, UDP packets, and so on. HPing has another functionality that is kind of useful. You can script it with TCL, and here in this example, I will build the same ICMP echo request message, and I will send it. However, because it's TCL embedded in the HPing binary, it's a bit difficult to use HPing in another tool, and also difficult to change the HPing behavior, because you obviously need to change the code that is developed in C. So before Scapy again, Philippe tried a prototype and developed a prototype called Pirate. It was developed in January 2003, so 2 or 3 months before Scapy was released. The code still works. You can get it online, so we decided to release it for the SharkFest Europe conference. So if you go to this website, you will find a single file, pirate.py, that is, let's say, Scapy ancestor. And why this code is really interesting, that it was for Philippe a way to validate the Scapy concept. For example, you can do protocol stacking. You can put one protocol on top of another. Pirate use default values. So for example, if you don't specify anything for the Ethernet destination address, Pirate will compute it for you. And also, Pirate is able to simplify packet injection. So let's have a look at that. Again, the code works with Python 2.7 without any modification, which is a bit, that's a big surprise because the code is 18 years old, still works today. It's quite amazing. So here, it's quite similar to the Scapy syntax. To stack the protocol, use a plus sign. So here we'll build an ARP request with with this specific string on top. Pirate was here, and the send function will send it at the layer 2. And Pirate will take care of everything. It will send the opcode in ARP, for example, to the ARP request value. Okay, so that's it for the things before Scapy. So let's have a look at the core Scapy concept. And to us, that's why this tool is so unique, and that's why people are using it. So default values. The goal of Scapy, again, is to ease your life. We don't want you to write a lot of code. We want you to focus on your work. And if you want to send a TCP segment to the SharkFest Europe website, the only thing you need to do is write this line. So you put TCP on top of IP, and you specify DST. That will be the destination address. And Scapy will take care of many things by default for you. For example, you will try to, so we are trying to be smart when selecting this value in the code. Scapy will use the destination port of TCP. It will set the value 80, which is most of the time a port that is open. So it means that your TCP segment will be able to exit your network and reach the destination. And for the IPTTL, we use 64, which is a regular values that most of the TCP IP stacks are using. On the other way, for, let's say, the dynamic values, Scapy will compute them for you. So in the case of TCP, it will compute the checksum, the length of the segment. And for IP, it will also compute the same values and try to select the correct source address, giving the internal Scapy routing table. Protocol layers, another big aspect of SCAPI. You can stack the layer with slash operators, and you can do really everything you want. So SCAPI will be able to give you the bytes, the binary representation of this really strange packet. So here we put ARP on top of IPv6, up on top of DNS. So of course this is not valid, but SCAPI gives you the opportunity to write this kind of really strange packets, strange sequence of bytes, and send that to the network. Because we are based on Python, every layer is a packet object, is a Python object. And internally, in a packet object, if you want to define a protocol, the only thing you need to do is to define a list of fields. So let's have a look at that briefly. Here is a snippet of the implementation of UDP in SCAPI. I will just focus on the field desk list. So here we have a list of 4 short. So we have short enum field, source port, short enum field, destination port. We can see that we have the default values here, which is the DNS port. And we have short field and X short field. So in this example, you can see it's really simple to define this 4 shorts. And you can see that internally, you can use many different types for the same value. X short field means that the integer will be displayed as an hexadecimal value when you print the UDP packet. And short enum field, just a simple way to say that when SCAPI will decode 53, it will look in this dictionary called UDP services, look for the 53 key, retrieve DNS as a string, and DNS will be written as the source port name when you will display the packet in SCAPI. So again, really efficient. You just need to focus on the field definition, and SCAPI will take care of encoding and decoding. Of course, there is more code in this UDP implementation because code is needed to compute the correct length and compute the checksum. But UDP implementation is not that long, just way too long to describe on a single slide. Building and parsing, really important feature. So if you call the raw function on SCAPI object on a packet, you will get back the binary representation. So before SCAPI version 2.4.0, it used to be the str function, and we decided to use raw because nowadays we support both Python 2 and Python 3. And the main problem is that in Python 3, str is not a valid function to be called on this packet. So to have the same interface in Python 2 and Python 3, we are using a raw, which make more sense anyway than str. So data will contain the binary representation of this UDP packet on top of IP. And because in SCAPI, each layer can parse itself, you can feed the IP header, the data bytes, and retrieve the value in P. And if you type p.ttl, you will access the TTL field, and you can check that it's equal to 42, because that's the value that we used here. Again, nothing really fancy, but it's really simple to build and parse packets. Ease of use, again, there is no external dependency, so you can just clone the repository and you're good to go, which is also, when dealing with network debugging, really interesting, because from time to time you need to send many specific packets. From time to time you don't have dependency installed on the system you want to debug. So being able to easily get SCAPI code and send whatever you want by typing commands on the shell is really, really powerful. Also, if we want to discuss the security side, it's really useful because from time to time, when you do a security pen test and audits, you discover, let's say, old machines with a really old Python 2 interpreter. So it's also really convenient to be able to launch SCAPI directly without any dependencies. It could be the case, for example, for small ARM routers with ARM or MIPS implementation. SCAPI will work on this architecture too. So there's plenty of useful functions integrated into SCAPI. Sniff, obviously we sniff the packets. like Wireshark or TCP does. We have also a Wireshark function, and the goal is to feed Wireshark some packets that are available in SCAPI. So what you could do, for example, sniff the network, modify the packet with SCAPI, and then open them in Wireshark to have a nice graphical interface to go through these packets. SR send and receive packets. That's the main SCAPI feature. You send one packet, you receive one answer. And we have also more, let's say, visualization command like xdump that will give you an hexadecimal view of the packet or the bytes that you are providing to this function. Okay, so that's it for the concept. So let's discuss what I'm calling the SCAPI takeoffs, or the use of SCAPI after the release in 2003. And after 2003, SCAPI gained more and more powerful features. And one of the first one it gained was answering machine. Answering machine is the goal of answering machine is to do exactly the opposite of SR. SR send and receive, and answering machine wait for a packet. So it receive and then send. So we'll wait for something and send back an answer. So it's really interesting if you want to simplify queries and answers interaction. For example, you can build a really simple DNS server, really simple DHCP server. And the next example, what I want to show is briefly how you can build really simple and fake 802.11 access points using an answering machine. Again, I won't go into the code in details because that's not the most interesting thing to do during a keynote. However, we'll describe two functions. The first one is called isRequest, and that's one function you need to implement for an answering machine. And this one is really simple. It just checks that in the 802.11 frame that you receive, you have the .11 probe request packet. If you don't know, in 802.11, the probe requests, they're sent by a smartphone, for example, when it looks for surrounding access points. And the access points, when they receive the probe request, they will send an answer, which is a probe response containing the name of the access point. So what we'll do in make reply we'll build the .11 frame. Basically, we'll use request in order to use the source MAC address of my smartphone. And then we'll build here the probe response with the fake name, which is SCAPI. And if you start this answering machine with your wireless network card in monitoring mode, then you will be able to get this screen on your smartphone. So that was my iPhone. You can see there is a fake SCAPI access point. Obviously, if you click on that, nothing good will happen because this fake answering machine is not a real access point. It's just replying to probe request. So that's a really interesting feature, and it's not a live demo, but it can show can show the power of SCAPI. You can inject many kind of frames, and you can do really interesting things with answering machines. So IPv6 was also something really big that happened in 2005. Really big because IPv6 specifications are kind of huge, and we decided to implement many protocols like NDP, DHCPv6, and so on. And at that time for us, the goal of this IPv6 implementation was mainly to learn and to experiment. And on the way of learning and experimenting, we managed to find a bug in Cisco iOS and XR routers. When you send them, let's say, a weird formatting routing header, it will crash them. So that's a bug we discovered in 2006. I guess January 2006, it took 1 year to be fixed by Cisco. That's why the CVE date is 2007. And something we also did, we played a lot with routing headers. So if you don't know IPv6, routing header is really similar to source routing in IPv4. And we discovered that there was a lot of implementation mistakes with routing headers. And we did a presentation in 2006 that ended up with this RFC 5095, and the routing header type 0 were deprecated. So nowadays it's not possible to use these routing headers on the internet because of us and what we did on the development we did on SCAPI. UTSCP was also a big improvement. So that's mainly a tool to write unit tests. And at some point in the SCAPI development, it was really needed, especially with IPv6, because again, the specifications are huge. And we tend to break the IPv6 support from time to time by adding new features. And also when we are dealing with the core of SCAPI, so receiving and sending packets, from time to time, we also broke stuff, so it was really important to have some regression tests. So Philippe wrote a tool called Unit Test SCAPI, which is a dedicated tool for SCAPI to write SCAPI regression tests. So you have to keep in mind that UTSCAPI was released in 2005, and that time it was, and to my knowledge, there was no other tool dedicated to do unit test on Python. And PyTest, which is one of the main framework that is used today, was released in 2005. So at the same time that we decided to write UTSCAPI. UTSCAPI is not really a fancy format. It's mainly a Python code, SCAPI packets, in between markups, like the stuff you can get with Markdown. If you launch the tool, by default, you will get the results on your shell, on the console, but you can ask UTSCAPI to output the result as HTML. For example, here that's a campaign I launched on my laptop. And here, if you want to have a look at why the test 11 failed, you can click on it, and UTSCAPI will expand on your web browser the test, and then you can see that there's some assertion error, and you can then debug. That's again really convenient tool when you are developing and changing stuff in SCAPI code. So we discussed sending and receiving packets. We discussed receiving and sending packet, but from time to time, this one-to-one model is not enough. And there is a way in SCAPI to define a state machine and to extend this question and answer model. So what you need to do, you need to define an object, define states, and then conditions and action when you move from one state to another. So on the right side of the slide, that the TFTP read state machine that you could use to download a file from a TFTP server. And you can see that we'll go from waiting to receiving, depending on some timeouts. And when there is no more packet to receive, we'll go in the end state. So it's really simple state machine. We have a more complex one, which is dedicated to TCP. We call it TCP client. And with TCP client, you are able, for example, to download a file over HTTP, over TCP using SCAPI. That's, again, something you can decide to implement. Pipes. This feature is not really well known. I don't use it much, to be honest. However, it's really powerful, especially when you need to do some really specific interaction with the network. So the goal of pipes is to use some kind of building blocks, put them together, and the goal of these building blocks is to allow you to do some kind of complex network data management. Something you could do is have a building block which is a TCP listener. So every time a packet or data will reach a TCP listener, the TCP listener will take the data of the TCP segment, send it to the next block. Next block could be, for example, a function that will display the value in the SCAPI shell and also write this value to a pickup. And finally, the final block that will get the same value will take this value and inject it over a BLE, Bluetooth Low Energy link. So that could be a simple way to automate injecting Bluetooth Low Energy frames using a Raspberry Pi from, for example, a web browser or another device. So here on the right, that's a use case that is related to Wireshark. In that use case, we'll sniff packets, like SCAPI does. We'll transform the packets and we'll display them in Wireshark. That's an example that you can find in the SCAPI documentation. Again, I won't go into details. We'll focus on the blue parts. Here, source, that's just a sniff source. We'll plug it with this sign into the transform drain. Transform drain will apply a function to each of the packets. And if you have a look at the content of this function, what we are doing here, checking if we have IP, and then we'll anonymize the source and destination address. We'll put them to 1111 and 2222. And then we'll send this transform packet into Wireshark. If you start this code locally, Wireshark window will pop, and then all of this IP and destination address in the two columns will be 1111 and 2222. Okay, another tool that was implemented, I think before 2010, was traceroute. So nothing really fancy. It's a typical TTL-based measurement tool, but there's a twist. First, you can select several targets at once. So you can probe the Google DNS web server, the Cloudflare DNS server, as well as the SharkFest Europe website. And one really interesting feature is that you can change the payload. You can decide to do a traceroute using a DNS payload. You can decide to do a traceroute using internet key exchange payload that is used for IPsec. And that is really useful. So in one of my previous companies, we are using IPsec a lot. And from time to time, it was not possible to communicate from one location to another, one network to another. And by using SCAPI with the specific Ethernet key exchange payload, we are able to traceroute and see which equipment, which router or firewall on the way that was actually dropping the packets. It's really convenient to debug. Can you actually send the same packets as the Linux stack doing IPsec? So not only we have these features of checking the payloads and doing traceroutes to multiple targets. We can do many different visualization. So you can put the routers, the results in a world map. You can do a nice 3D representation that could be useful if there's a lot of nodes in the results. And something I really like, that this presentation. So SCAPI will do its best by talking to WIS servers to do its best to aggregate the public IP addresses per autonomous system. So in this example, I did a traceroute to the Google DNS server, to the Cloudflare DNS server, and to the SharkFest Europe website. So here in red, we can see that 8888 is not answering anything on the port 80 on TCP. That is a default payload that SCAPI is using. And really interesting information here that we can see that SharkFest Europe is actually hosted by Cloudflare because it's the same autonomous system as 1111. SCAPI 2.0, a big part of this story. So it was released in May 2008. So it's a big part of this story. It makes me smile because before that, SCAPI was a huge file, single file of 14,000 lines long, which is not really convenient if you want to do some specific imports, not also really convenient if you want to do development between the different people, because it's not really simple to do a single modification, and you can have conflicts when you want to merge the files. So Philippe decided to split everything using this hierarchy. So it's a regular Python module. I will only describe a few of these directories. So Arch, that's the architecture. That's a platform-specific code for Linux, FreeBSDs, and Windows. Layers contain all of the protocol layers that we support. And let's say that these ones are enabled by default. And they are protocols that you can find on the typical LAN. For example, there is no BGP decoding enabled by default in SCAPI. There is no ZigBee enabled by default because that's not something that you usually find when you launch TCP dump or SCAPI in sniffing mode. Contrib, it used to be a directory where people can put their own code. The meaning changed, but we kept the name. Let's call that some new or exotic protocols. So in that, you will find BGP, HTTP2, ZigBee, things related to mobile phone like GPRS, so GTP. And then this kind of protocol, you need to load them manually and ask CAPI to decode them for you. Okay, let's discuss a part that is a bit sad. After 2010, there was less and less commits, and the Scapy project was pretty much dying. So why? Because Philippe was alone. He was the only developer. He didn't have much time to work on the project, and the contribution were also really difficult to make. At that time, the project was hosted on Philippe's own website, on server. It was really difficult to give access to new contributors because Philippe had to create an account. He had to give them access to the code. It was not as convenient as with GitHub, Bitbucket, or GitLab these days. And in the end, there was no release for almost 3 years. And at that time, in 2013, Philippe decided to move to Bitbucket, to move from Subversion to Mercurial. It was a little bit easier because in that case, you could create an account on Bitbucket. You could push pull requests. You can open issues. It was also much easier for the maintainer. And that's around that time that Philippe asked us to take over the project. However, because nothing really happened between 3 years, when we took over the project, let's say maintenance effort was huge because we had to go through all of the previous issues, all of the previous pull requests. Some issues were indeed questions, so it was a lot of work just to try to sort all of these issues in Bitbucket and in the mailing list also. So yeah, that's why we didn't do a release really soon after we took over the project. And this loss of speed and the loss of commits can be seen here in this graph. So that's something I got from GitHub. You can see that when the project started, there was a lot of commits. Then version 2.0 was one spike, and then nothing really happened before version 2.3.0. That's indeed the first release that we did as maintainers with Pierre, and I think at that time Nicolas Barret was helping us, and that was, let's say, the maintenance effort. So we had to go through issues and so on and test new things. So that was the first release after Scapy kind of died. So let's have a look at the rebirth. So rebirth, from my point of view, happened in 2016. So why? Because Pierre Lallet decided to move the project from Bitbucket to GitHub. And to me, that's one of the best choice that someone ever made for the project. And by doing so, we also moved from Mercurial to Git, and it was really huge. We get better project visibility. So Bitbucket it's like the dark web of open source development. It's really difficult for people to go to Bitbucket and help you with your project. And as soon as we moved the project to GitHub, a lot of people contributed. So it was really, really good. And also we were able to benefit from the GitHub ecosystem. We use Travis and Abeyer for CI, continuous integration. We are using another tool called CodeCov to get a really nice display of code coverage. We use some other tool to discuss with the community. So it was really helpful to go to GitHub and then get all of these free and interesting services. CI, it was the first improvement we made after the GitHub migration. And at first we decided to start the UTScapy script automatically. And the goal for us was to catch bugs when we are pushing regression tests and catch bugs across Python version. At that time it was 2.6, 2.7, and so on, and across platform. So as of today, we are testing on different platform, macOS, Windows, Linux, and also on different Python version, 2.7, 3.8, 3.9, and so on. Python 3, so big subject, big topic for Scapy. Again, if we go back in time, the project was pretty much brand dead. Then we took over the project with Philippe, and in 2015, some people from the community asked us what will be done for Python 3. And obviously, we didn't have time to do that. And at the same time, Philippe wrote a proof of concept called Scapy 3.0, which was a complete rewrite in Python 3. And to us, it was the best option at that time, 2015, to take some time to have a look at the proof of concept and modify it in a way that it will be the Scapy successor. However, and again, because we are doing volunteer work, we don't find any time to do two things at the same time, which are maintaining Scapy 2.3.0 and the other version, and having a look at Scapy 3. So we decided to stop this idea of Scapy 3, and we decided to keep Python 2 compatibility. So the current code is both Python 2 and Python 3 compatible. There was some initiative, there was a fork that was only Python 3 compatible, but obviously, because still many people are using Python 2, the best choice was to do both language in the same code base. A big issue that we had at this time, that's back in 2016, the unit test only covered 50% of the code. And it was like really likely that pushing for Python 3 compatibility will break more stuff. And we wanted to make sure that this modification won't break any good code. And also like moving an old project from Python 2 only to Python 2 and Python 3 was a big effort. And we didn't want to make a huge single commit that will modify all of the files in the project, because that will have been a mess to review and merge. So we decided to, let's say, divide and conquer and use two different strategies. So internally, we had two projects. The first one was named coverage, and the goal was just to enhance code coverage. So it took in between 6 to 8 months to go from 50% to 85% of code coverage. And at the same time, we started the convergence project. And the goal of the convergence project was to introduce small Python 3 changes that were like going, and the aim of these changes was to have a full Python 2 and Python 3 compatibility. It took close to 1 year for convergence to be achieved. It took 1 year to activate Python 3 in the unit test in Travis. And then it took 2 or 3 more months before doing the release. So it was still a lot of debugs. To be honest, from time to time, there's some people like on the GitHub issues that are finding bugs in the Python 3 implementation. So from time to time, there is some part of the code that are still not yet compatible with Python 3, but it's not really frequent. Maybe we receive one such issue per year. So coding conversion, so it was another big topic. No coding conversion was enforced in Scapy code. The code was a bit messy and not really, let's say, clean. So that was a bit confusing for new contributors because they didn't know what to do. Should they modify everything in a file that I'm modifying? Should they only comply with PEP8, which is a Python coding style in a single function? So anyway, it was really difficult to explain. And we decided to switch and apply the PEP8 to the code. Again, we had some constraints. We wanted to credit the original authors. We didn't want someone else, and then Philippe, indeed, to take over the commits and say, okay, basically I wrote all of the line in Scapy. We wanted to preserve the Git history. So we wanted to make simple commits. And also because there was a lot of issues with the coding convention. There was a lot of errors. We wanted to do simple pull requests and simple to simplify reviews. So we decided again to do some divide and conquer strategy. And that time we did one commit that was modifying a single class of bugs, for example, adding a space after a comma, or changing the way lambdas are written and so on. So each commit were a single modification of the code base. It took close to 4 months to move the code to PEP8. And nowadays, if you commit code to Scapy, the CI will enforce the coding conversion. Another big thing we got when during the rebirth of the project was the native TLS and X509 support. And to me, it's really interesting because it was, again, a support to learn TLS 1.3. So what you could do, you can sniff TLS packets. You can encrypt or decrypt TLS messages if you have the keys, private or symmetric keys, and you can manipulate certificates. So certificate manipulation is really interesting because you can easily extract one TLS certificate from the TLS certificate message. You can parse them, display the content, verify signatures, and if you have the corresponding private key, you can also change the values and resign. On this slide, the example is really simple. So I downloaded two certificates. The first one is a SharkFest EU certificate. The other one is a Cloudflare certificate, the CA. And then I will just use the issuer_cert function to check that the cert Cloudflare is indeed the issuer of the SharkFest EU certificate. So it's a really nice and convenient interface to play with this complicated and complex objects. Automotive, this contribution was a big surprise to us. I think that's the biggest contribution to date. So the goal was for their developer to use Scapy for automotive pen tests. And by doing so, they decided to add a lot of automotive related protocols from data link to application layer. So maybe you know CAN, the CAN bus that is used in modern cars, or OBD. So we have the implementation of these protocols in Scapy. And because we have that, it's really simple to forge, sniff, and do some man in the middle in cars and in internal cars network. So it's a really interesting feature of Scapy and that you can use today. There is a lot of documentation, and that's we are really, really proud of this contribution. Marketing, that will be the last slide that will discuss the rebirth of Scapy. So first, what we decided to do to reach out the community was to get a logo. So we asked a friend, Ben Renaud, to design it. So that's the logo you have here. That's the one on my t-shirt. And for us, it was really important to associate Scapy with a really nice and cute design. So we are trying to reach the community also by doing tutorial during conferences. So we try to go mainly to security conferences to teach about Scapy, how people can use it. We go to engineering schools and university to teach network class. For example, I teach IPv6 classes, and I use Scapy a lot to give students a deep understanding of protocols and IPv6. And also we are discussing with the community with chats. Regarding documentation, so during a long time, the Scapy documentation was close to 0. We decided to have some kind of, let's say, chain of documentation. So first you can start with a README, which is really simple, really not really long, but in the README you will find everything you need to start and type commands. You will find also links to documentation. If you want something more, let's say, dynamic, we did some IPython notebooks that you can follow. That's, let's say, in between a real documentation and a tutorial. And finally, you have the website scapyreadsthedocs.org with many examples of the project. So the presentation is almost over, but I want to finish by discussing some use cases. Again, they are mainly related to security. So exploits, so in security, let's say language, an exploit is a piece of code that you will use to execute anything you want on a target. Something we are really proud of, that's an exploit called Extra Beacon. It was written by NSA, and this extra beacon code leaked to the internet in something called the Vault 7 leak by WikiLeaks. So I'm really proud I have my email and my name in an NSA leak on WikiLeaks. And this code was really cool. It was using the SNMP SCAPI implementation, because we also do a SN1, to trigger remote code execution on Cisco firewall called ASA. The IPv6 implementation of SCAPI is used really frequently to be able to demonstrate, to write proof of concept, to demonstrate exploits against IPv6 or to execute code. And during the last 2 years, it was used to demonstrate these 4 CVE. 2 of them are related to fragment header and the other one to router advertisement. So it's, again, really good for us when we see that people are using SCAPI to really easily inject packet to the network, modify the packet the way they need to actually trigger code execution. On the wireless side, SCAPI is also used for Wi-Fi. It was used in the crack attacks, and recently, like 1 month ago, it was used in the frag attacks. So again, for us, that's a really cool gift when people are using SCAPI to do that. Concerning BLE, during the last 2 to 3 years, it was used twice, to my knowledge, to implement the Sweeney tooth attack and the blur tooth attack. So that's kind of mission complete when people are using SCAPI this way. On the network side, SCAPI is used as unit test, and to my big surprise, it's used in most of the regular, let's say, open source operating system. It's used in Linux, OpenBSD, and FreeBSD to test the TCP/IP stack. And on OpenBSD and FreeBSD, SCAPI is more specifically used to test the IPv6 layers, and that's basically a regression test for them. And the eBPF ecosystem is getting bigger and bigger, like since 2 years. And some big projects are using SCAPI to do unit tests. It's like the first one is Facebook Catron, and the other one is ExpressDNS. So again, for us, it's a really, really nice gift, and we can see that people appreciate and use the projects. So if we look at the next step and the future of SCAPI, briefly, improvements. Gabriel is working on a Python type annotation. So Python is a dynamic language. However, you are able to write some type annotation saying, okay, I want this specific argument to be an integer, and I want you to check that. That's really helpful because by doing the static analysis this way with the types, we're able to catch some bugs from time to time. And Gabriel managed to catch some, let's say, difficult bugs with that. I'm working on eBPF for SCAPI, and my goal is to do per process sniffing. So for example, what I want to do, I want to be able to tell SCAPI to sniff all of the packets that are sent by the curl command. And obviously eBPF, that's the way to go. I have a proof of concept that's not really yet. Another big question that we will likely need to answer in the next 2 to 4 years is to question the Python 2 support. Should we still support Python 2? Should we remove it? So that's a difficult question. So we'll see how it goes. We'll see if people are still using Python 2 with SCAPI. And then we are also doing some experiments, something we called just in time. So in SCAPI, we have each packet is defined by a list of fields. So every time we decode a packet, we need to iterate on the list of fields. Something we would like to experiment with is to, instead of iterating the list of fields, we like to convert these fields into something more static, just to that's why we call it just in time, just to make the decoding faster. Lazy parsing was also is an interesting topic. So that was one of the new concepts that Philippe introduced in SCAPI 3.0. The goal is to say that we don't need to decode and to take time decoding, for example, the TLS certificate, if we don't use the TLS certificate. So if you don't access the certificate information, there is no need to parse the ASN1 content. And finally, we are playing with Rust, and the goal for us is there's two goals. First is to learn Rust and to see if we can have a similar SCAPI syntax in Rust using the Rust macro. And the other idea was and is to improve the speed of SCAPI. So if we write the core SCAPI coding and decoding and encoding in Rust, we hope that we could enhance SCAPI performances. And that's it for me. So if you have questions, please ask them on the chat, Discord, I guess, or I think there's also an open mic session. So please ask me questions. Thank you.
There's one question from Soccer Blog. You want to answer that one? People won't be able to turn on their mics, but they will be able to type the questions.
Thank you. Thank you, Dimitri. Thank you. Thank you. Reading the messages.
So Zoom's kind of weird in that there's separate chat and Q&A, but in the Q&A section, Socket Block was asking if the traceroute visual output looks a lot like a UML generated picture.
Okay. Question is related to the traceroutes.
Yeah.
So UML, it's indeed SCAPI is building a dot file. So grab this dot file, and then it calls a command to convert the dot file to any output format. In that case, it's SVG because it's really convenient to read SVG and Zoom in a web browser.
All right, cool. Thank you. That was a great session. Thanks.
Are there any example on how to do this create dot file?
Yeah.
Let me check. Yes, I will just give you the link of the presentation. Yes, it should be in the documentation. Let me check.
Okay. I'm being signaled that it's time to wrap up the session, but you know, we do have the Discord chats open. But again, thank you, Guillaume. This was a great session.